Welcome back, everybody. This is the last section of chemical bonding that we're going to do. This is part 9. And in this part, we're going to take all this stuff, the polarity and the electronic and the molecular geometries, and we're going to put all that stuff together. So when we're doing this, just to summarize, you draw the Lewis structure, you determine its electronic and molecular geometry, and then you look at the polar bonds, and then you decide if they form a net dipole moment or if they cancel each other out. And as I mentioned earlier, it's important because a lot of times we're looking to see if something's going to be soluble in water. And so this is a critical piece of information. If it's nonpolar, then it will be. So in deciding if it's polar, one of the ways you can do this is you draw the Lewis structure, okay, and then you determine if it's got any polar bonds, and we know it's got those 2 electrons up here, and we know that it will be in the direction of that nitrogen, and so that definitely is going to create a dipole moment in this molecule, and so it would be a polar molecule. The other way you can do it, though, is you can look at it from the standpoint of the molecular shapes, and this is a little bit different, so I'm gonna go through this with you just to kind of show you. So we know that a non-bonding electron pair is a lone pair, and it's not shared, right? And an electron group is a lone pair or a bonding group, and the bonding group can be single, double, or triple bonds. Still counts as one group. Okay, so let's look at this one first. We've got SO3 2 minus. So how many electron groups does that have? It has 1, 2, 3. So it has 3 groups. So we're going to look back and say, okay, what is the electronic geometry? It's trigonal planar because it has 3 electron groups. It doesn't have any lone pairs, so it's just an AB3. Now I can look back on the chart, but I don't really have to, because if it doesn't have lone pairs, I know that it's still trigonal planar. Now, is this polar or not? Now, I'll tell you a clue. The shape. The shape is a triangle, trigonal planar. It's all in one plane. There's nothing sticking out. So that means it's symmetrical, and so the sulfur is being pulled in that many different directions, and so they would cancel each other out. So this would be non-polar. And we know non-polar molecules will have dispersion forces and van der Waals. All right, so the second part of this, it's PCl3. Okay, so we got to draw this one. So PCl, Cl, Cl, NASB. So 1, 2, 3, 4. So 8 times 4, 32. And then I have phosphorus is in group 5. So I have 5 plus 3 times 7. 7, 14, 21. So that's 26. So I have 26. 32 minus 26 is 6. And 6 divided by 2 is 3. So it says it has 3 bonds. So I got that. All right. And so I got 26 electrons to play with. So 26 minus the 6 I have in bonds is 20. And then I've got 1, 2, 3, 4, 5, 6. Oops, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 on the terminals. I have 2 left over, so those go right there. Okay, so I do have lone pair on this one. All right, so how many groups do I have? I have 3 bonds and 1 lone pair, so I have 4 electron groups. So when I have 4 electron groups, then it's tetrahedral, electronic geometry. My AB formula is AB3U. And so if I look back at my chart, AB3U is pyramidal. Now, is this thing polar? Well, yeah, because it's got 1 lone pair and it's got nothing to offset that. So it's going to make this molecule kind of do that, okay, and kind of squish it. All right, and that's why it forms a pyramid. And so if it has that lone pair up there, it is polar because it has more negative on that end than the other end. And so intermolecular forces could be dipole-dipole. Okay, and we're going to look at intermolecular forces more later in the semester. Okay, so what this does is it sets you up to be able to go all the way across with these, draw the Lewis structure, do the number of electron groups, get the electronic geometry, the AB formula, the molecular geometry, whether it's polar or not from the shape, and then the intermolecular forces. We're not so concerned about those yet. Okay? So this is an example in lab number 5 of these molecular shapes. And that's it for chemical bonding.